In this lesson, we'll go ahead and learn to solve quadratics using the factoring method. As we learned in our last lesson, we can solve a quadratic by graphing it by hand or using the Desmos graphing calculator. Part of that is using the factoring method to find the roots or the zeros. In our next lesson, we'll go ahead and use the square root method, and we'll learn about the quadratic formula as well as completing the square. For the factoring method, we want to set our equation equal to 0, factor, either as the GCF, the difference of perfect squares, or a trinomial, and then we set each factor equal to 0 to solve. So we'll take a look at our first example here. It says r squared equals negative 2r. We want to go ahead and set our equation equal to 0, and I'd like to keep my r squared positive. So I'm going to draw my line down my equal sign, and I'm going to add 2r to both sides of my equation. In doing that, I've got my r squared plus 2r, and it is now equal to 0. We always want our equations set equal to 0 because when we think about graphing a quadratic, which is a curve, it should cross, usually, the y-axis in 2 places, or maybe even only in 1 place, but wherever it crosses that x-axis at, the y value is always equal to 0 because this is an x-intercept. So that's why our equation is set equal to 0 here. If I remember my factoring, I want to look to see if there's a GCF here, and in this case there is. The r is the greatest common factor, so I'm going to pull that r out and divide everything by r, and I'll get this, r times r plus 2. Then we'll go ahead and take these two factors and set them equal to 0. We have r equals 0, and we have r plus 2 equals 0. These two little mini math problems need to get solved for r, and those are our solutions to our quadratic. So here I have r equals 0, that's already solved. Over here I have to subtract 2, and I'll get r equals negative 2. So here you can see we have two solutions to our graph. And this is, again, the roots, the zeros, the solutions. This is the x-intercept. This is where our graph crosses the x-axis at 0 and at negative 2. Our next one, we're going to do the same process. We're going to solve for our equation set equal to 0. So I'm going to go ahead and put my line down, and the 16 I want to move to the other side, so I'm going to subtract it. When I rewrite it in good form, I've got 25y squared minus 16 will equal 0. Okay, I don't have a GCF in this case, but I do have the difference of perfect squares. 25 is a perfect square, y squared is a perfect square, 16 is a perfect square, and we're subtracting, so we can go ahead and factor that way. We're going to write 2 parentheses, set them equal to 0. Our parentheses are taking the square root of everything, so that's 5y and a 4, 5y and 4. And then our parentheses, one has the plus sign in it, the other has the minus sign. Once you're done factoring, you take each factor and set it equal to 0. So we're going to take 5y plus 4 and set it equal to 0. And we'll have to solve this two-step equation, which means we subtract 4 on both sides. And then we'll divide by 5 on both sides. We'll get a y value that's equal to negative 4/5. That's one solution. And we'll have to do the same for our other factor. So we have 5y minus 4 equals 0. We're going to add 4 to both sides and divide by 5 on both sides. We'll get y equals 4/5. So here we have our two solutions, our two roots, our two zeros. This one would be a little bit trickier to graph because our zeros are these fractional pieces, and this is why maybe that square root method would be more helpful than graphing it by hand. We'll take a look at our third example here. We have a squared minus 9a equals negative 14. Again, I want everything over on one side of my equation. I'm going to leave the a terms exactly where they are and add 14 to both sides. This is now a trinomial. It has 3 terms. The leading coefficient is a 1, so this is our type 3 factoring where we go right to an X box to help us organize our thinking. The last term goes in the top of our X box, and that's what we're multiplying to. The middle term coefficient goes in the bottom of the box, and that's what we're adding up to. So we're thinking of 2 numbers that will multiply to 14, but we'll need to add to negative 9. Now, I think it's a combination of 7 and 2. 7 times 2 multiplies to 14, but it's not going to add to a negative 9, so we're going to need negative signs for both of these. Keep in mind a negative times a negative will get you a positive value, but when we add 2 negatives, we just get more negatives. Now, we learned that in a type 3 trinomial, when the leading coefficient is 1, the side pieces here to this X box are our factors. So we're going to go ahead and make our factors a minus 7 and a minus 2. If you want to go ahead and do type 4 factoring, which is factor by grouping, and split this negative a term into 2 pieces, and continue with that method, you're welcome to do that. It'll get you the same value. All right, we're going to set each of these factors equal to 0. So we have a minus 7 equals 0. We have a minus 2 equals 0. As we solve this, we would add 7 to both sides. We would add 2 to both sides. We have 2 solutions here. So this is our factor by grouping, our factor solving by factoring method for quadratics. The bottom 3 examples mirror the ones at the top. So if you'd like to pause the video and try the bottom ones with the work from the top as your guide, feel free to do so. Otherwise, I'll continue to work on the bottom 3. Our next one, we're going to go ahead and set equal to 0. So I'm going to take this 6g and move it to the other side by subtracting it on both sides. So my new quadratic comes out to be 6g squared minus 6g equals 0. This is a GCF, greatest common factor type of factoring. So we're going to take the g out, divide everything by g, and we'll have g minus 6 equals 0. Then we set both of our factors equal to 0. This one's already solved for g. This one we have to add 6 to both sides to get a g that will equal 6. So our 2 solutions, our 2 roots, our 2 zeros, our 2 x-intercepts are at 0 and at 6. Next one is our example of the difference of perfect squares. I'm going to subtract 49 on both sides. We'll get 36z squared minus 49 equals 0. Again, this is the difference of perfect squares, so I'm going to take the square root of everything and set 2 parentheses equal to 0. I'll have 6z plus 7 and 6z minus 7. We'll set each of these factors equal to 0, and then solve from there. They're 2-step equations, so I'm going to get rid of the constant term first. In this case, I'm going to minus 7 on both sides. I'll get 6z equals -7. Then we'll divide by 6 on both sides. And our z value will be -7. Six. Oh, I wrote a G. 6. Ooh, there we go. On this side, we're adding 7 to both sides. And dividing by 6 everywhere, we'll get our z here to equal 7, 6. So we have 2 solutions for z. Again, this is where our graph will cross that x-axis at. Our last example is our example of the trinomial. We're going to go ahead and move this -8 to the other side by adding it to both sides. So we'll have x squared minus 6x plus 8 equals 0. It's a trinomial with the leading coefficient of 1. So I'm going to go ahead and go to my x box. My last term goes in the top for multiplying. My middle term coefficient goes in the bottom for adding. And now I'm trying to come up with 2 numbers that multiply to 8, but would add to -6. A combination of 4 and 2 will work, but they both need to be negative. Our side pieces to that x box are our factors. So we'll write x minus 4 times x minus 2 equals 0. And our last piece is to set each factor equal to 0. We're making 2 separate equations that equal 0. And then we're solving by adding 4 to both sides, adding 2 to both sides. And we'll get our 2 solutions. That is your solving quadratics by use of the factoring method. Next video will be on square roots, and after that, the quadratic formula.